The Algebra 2 class is going to be starting its unit on exponents and logarithms. So this first slide is just a general review of your laws of exponents. And in this lesson, we're going to be focusing on this law right here that deals with rational exponents. When you encounter a fractional exponent, it's really representing a radical expression where the denominator is the index and the numerator is the exponent. And we're going to look at why that works. So in order to do that, we're going to review our law of exponents when we multiply common bases. So when we multiply common bases, so let's say I had 9 raised to a half times 9 raised to a half. So when we have common bases, we can add the exponents, and a half plus a half is going to be a whole. So this represents 9 to the first power, or 9. And when you have a number that's being multiplied by itself and it results in itself, that's the definition of a square root. Let's look at another one. Let's say we have 16 raised to a third times 16 raised to a third times 16 raised to a third. So again, we're going to use our rule where we multiply common bases. We can add the exponents. And if we have a third plus a third plus a third, we have 3/3, or 16 to the raised to the first power, which is just 16. And when we have a number times itself 3 times that results in itself, that's the definition of a cubed root. So this law, or this rule, worked with a half and it worked with a third, and in fact it works in general. So we know that we can rewrite this expression as a raised to the m power under a radical where your index is n. We're going to practice going from exponential form to radical form. So as we said before, our denominator represents our index and our numerator represents the exponent. So we can rewrite this fractional form in radical form. So this is going to be 64 raised to the second power with an index of 3. So let's go ahead and simplify this. In order to simplify it, we're going to break this down into its prime factors. So 64 is 8 times 8. 8 is 4 and 2. 4, 2, and 2. So now I'm looking for numbers that show up 3 times. So we have a 2 that shows up 3 times, and we have another 2 that shows up 3 times, which means that we can pull out from under the radical a 2 and another 2. But you guys, think about what this means. This actually means that I have 64 times 64. So we have this happening twice. So in actuality, we have 2 times itself 3 times, 2 times itself 3 times, 2 times itself 3 times, 2 times itself 3 times in 4 situations, which means we can bring 2 out from under the radical 4 times, which means we have 2 times 2 times 2 times 2, or 16. Let's try another one. So here we have 32 raised to the negative 3/5. So we can rewrite that as 32 raised to the negative third with an index of 5. So when we have something to a negative exponent, we know that that really belongs in the denominator. So we can think about this as 1 over the 5th root of 32 raised to the third power. We're going to go through the same strategy where we break 32 into its prime factors. So 32 is 4 times 8, 2 and 2 for 4. So here we're looking for a number that shows up times itself 5 times, and we have 2 that meets that requirement. So a 2 can come out from under the radical. But what we need to remember is that this is actually 32 times 32 times 32. So the fifth root of 32 is 2, the fifth root of 32 is 2, and the fifth root of 32 is 2. So the final simplification would be 1 over 8. We can also go the other way. We can go from radical form to exponential form. So let's try that with this first problem. So if we were going to rewrite this, this would represent x, where 3 is my numerator, and 6, the index, is the denominator, times y, where -2 is our numerator, and 6 is our denominator. The next thing we would want to see is, can any of these fractions simplify? And we can simplify 3/6 to 1/2, and we can simplify 2/6 to -1/3. And so now we've gone from radical form to exponential form. Looking at the next problem, we can write this in exponential form as well. We would have 9, where 1 is our numerator, and 5, our index, is our denominator. We would have a, where 5 is our numerator, and 5 is also our denominator. And we would have b, and because b is in the denominator, it's going to be -2 in the numerator and 5 in the denominator. Next, we would look and see, will any of these fractions simplify? So 1/5 doesn't. 5 over 5 is just going to be 1, or a, and b does not simplify either. So this would be the final exponential form. Now stop the video and practice converting these expressions into radical form. When you're done, start the video again and check your work. Now that you've restarted the video and you can check your answers, take a moment to write down any comments that you might have regarding questions, and we can go over those next class. Try these 2 problems. Pause the video and start it back up again when you're done. Now that you've restarted the video, jot down any questions you might have for next class. We can use what we just learned about exponential form to help us simplify expressions. If we can rewrite these in exponential form with a common base, we can use our other laws of exponents to help us. So if we look at 8, we can rewrite that as 2, where 3 is our numerator and 2 is our index, or our denominator. We can also write 4 as a base of 2. So that would be 2, where 2 is our numerator and 3 is our denominator. Now that we're multiplying common bases, we can add our exponents. Adding 3/2 and 2/3 results in the fraction 13 over 6. So if we're leaving it in exponential form, I can leave it as like that. Or if I wanted to put it back in radical form, we can do that as well. So this means that I'm looking for a number times itself 6 times. And I know that I have 13 2's, which means that I have 2 groups of 2 that can come out from under the radical. And we have 1 2 that would remain under the radical sign. So we would have 4 times the 6th root of 2. For the next problem, I see that I can have a common base of 3. So I can rewrite the numerator as 3 raised to the 2/3, and I can rewrite the denominator as 3 raised to the 1/6. When dividing common bases, we can subtract the exponents. When we subtract 2/3 minus 1/6, we end up with 3/6 or 1/2. So if we're leaving it in exponential form, we can just leave it like this. But if we wanted to rewrite it in radical form, we can do that as well. Pause the video and use what you've learned, plus the other laws of exponents to simplify these expressions. Check your answers and make any comments about any questions you may have. Hope you enjoyed the lesson.